All right. Thanks, everyone, for joining for our webinar this afternoon. I'm joined, so my name's Scott Young, Managing Director of CATCH Power, and I'm joined here by Marcus from Fronius and Richard from Noark. We're each going to do a presentation on our own position in the market, but the main thing that we're focused on and that we're celebrating today is the release of the new product from Noark, which has the backup box for Fronius inverters that includes the CATCH control. So it's so that's what we're talking about today. So I'll hand over to Marcus, and we'll go from there. Thanks, Marcus.
Yeah, thank you so much. Thanks for having me here in the webinar. As Scott mentioned, my name is Marcus Schmidt. I'm part of the Fronius Solutions team. I'm based in Perth, Western Australia, and I have the pleasure to guide you today a little bit through our portfolio. So yeah, first up on the agenda, we start with the Gen 24 portfolio as it stands. So what do we have in offer and what products we have? The next one, we talk heavily actually about the Fronius backup solutions, battery compatibility and what we can offer in terms of battery and what might be on the future plate, and some battery functions in more detail. And the last topic, which will then lead to the actual main event, is the full backup setup of the Gen 24 series. Yeah, here's our Gen 24 and Gen 24 Plus portfolio to make a Gen 24, Gen 24 Plus. That's easily done via a update, a FUB update as we call it. So let's have a look at the range we have currently on offer. So the Primo is the single phase inverter series we have, the power available in the power classes 3, 4, 5, 6, 8, and 10 kilowatt. And for the SIMO range as it stands, we have a brand new member to the family. Starting from the back, the 12 kilowatt is brand new. And then we have the 10 kilowatt, the 8 kilowatt, 6 kilowatt, 5 kilowatt, 4 and 3 power classes available at the moment. As mentioned before, the inverters, the hybrid inverters, actually perfect for the battery rebate. So it's a little bit of an introduction to our portfolio. So if you install a normal Gen 24, which is a normal grid-tied PV inverter, you can upgrade it easily to a Gen 24 Plus. So you would have plenty of opportunities to actually get the inverter ready for a battery to be connected, or do split installs to manage the cash flow as well. So install a Gen 24 today, and once the rebate is up and running, you can make the Gen 24 a Gen 24 Plus, and then add the battery as, for example, the rebate kicks in. So another advantage is the upgrade pathway allows you to manage also a huge volume of battery installs at the same time, if that makes sense. So you're not need to install a battery straight away. So you can do that through the update later on if you want it. Next up is, let's jump into our backup solutions and what the Gen 24 has to offer here. So our first solution is what we call PV Point. It's a simple separate AC power output from an inverter. So it's a single phase output more or less, which provides emergency power on one phase during a grid outage with max 3 kilowatt. So you could put that, for example, on a GPO or wire that back to the switchboard if you want to. But with PV Point will be only active if we do have PV available, or if you have a battery connected, then we would have power on that as well. But it's, again, here mentioned, I hope you can see my mouse, it's only powered by solar, or if you have a battery present, and it's only active during grid outage. So that means in grid parallel mode, when the grid is connected, PV Point wouldn't be active. For that reason, we recently introduced what we call PV Point Advanced. So PV Point Advanced is a solution where it extends the PV Point function with the changeover relay you can add. So the difference is you add a relay and it automatically changes over from grid powered to, when the grid is gone, to not grid powered. If you don't have a battery, it will only work when you have sufficient PV power actually on the terminals. Once the grid is back on, it'll automatically change back over to the grid connected ports. If you're interested in more and you do want to see more, we have an application guide, which is very good, which gives you all the details you would need to have. Or if you want to rewatch the webinar on the PV Point Advanced, please feel free to scan the QR codes here, which bring you directly to the content if you want to. So that's why I'm not going into more detail, because the focus on this session today is a different one, which we explore later on. Let's jump into full backup. So full backup, that's how full backup solution could look like in a Fronius world. I hope you can see my mouse. So we have here the main grid, and then we always need to have a Fronius smart meter or some sort of smart meter, which we explore later on, I guess, as well. And then backup switch or backup changeover gear, which could be a backup box. You choose your contactors, or a backup controller, which is basically then responsible to safely disconnect the grid when we don't have a grid connection and change it over to the Gen 24, which is powering then the battery / the house loads. So grid is gone. Then we isolate with the backup switch gear the house, and the Gen 24 would power up and support then via PV panels and or battery the house loads to fulfill the needs. Let's talk a little bit about battery compatibility. In terms of battery compatibility, we do have our Fronius Reserva coming soon. And we know that there are a lot of questions and a lot of people want to know more about the product. We're very happy to share more information within the next month on pricing, specs, and all what you need to know. But still, we do have the great setup with compatible BYD batteries. I just wanted to quickly go into the BYD battery box setup and the differences, which makes it a bit easier for you when you plan a system or when you have an existing customer to expand the system. So in terms of the chemistry of the BYD batteries, the HVS and the HVM are both lithium iron phosphate. They're both modular systems, and they pretty much differentiate in terms of capacity they could carry and also the power put through you would have. So both of them are modular. If you look at the HVS, 2 to 5 modules per stack, which gives us up to 12.8 kilowatt per stack. On the HVM, 4 to 8 modules, which can give us up to 22 kilowatt hours. If that is not enough, we can also do multiple stacks. So for example, if you are looking for the biggest size with the biggest power, then this table here comes in very, very handy, where we see all our inverters, charging and discharge range. And the things I would like to point out, as you can see here with the red mark around it already, if you look at the Gen 24 SIMO 10 Plus with a HVS with 10.2 kilowatt hours on, the system is able to deliver 9 kilowatt and charge with 9 kilowatt, which is quite a bit, compared to the HVM, where we have a similar size in terms of capacity with a lower charging or discharging rate. But with the HVM, as you can see on the right-hand side, we can do more batteries. Apologies for that, too fast. We can do more power with higher capacities on the HVM side. So this will really depend on the customer's needs in terms of capacity and power, whatever is needed. So please be aware of that. And here we have a setup, here we can see that you can actually do multiple stacks. So as soon as you have more than one stack, you would need a battery combiner box to actually combine them. So you can either do 2 or 3 stacks. So for example, if you want to have the largest size possible, then you would stack up 3 HVMs, 19.3, which would give us almost 60 kilowatt hours of capacity usable for the customer. Let's have a look about intelligent controls. So the Gen 24 also allows for intelligent battery controls, which relate to backup. And I just wanted to cover a couple of these features because some of them are actually quite new as well. Let's talk about a bit more in detail about Black Start. So if you go into the Black Start function under functions NIO in the web UI, where you can configure the system, this is actually called so, which will prevent the battery to turn off during the night because the SOC is, for example, at the lowest level. So it will prevent or keep the SOC there for longer, that the battery usually starts up in the morning again. So this means the battery and the inverter remain connected and the battery doesn't shut down as it usually would if you hit that really lower level SOC, if you have a couple of really bad days with not a lot of PV production, or the customer is using a lot of energy. So it's pretty much a safety mechanism to prevent deep discharge and gives the customer more flexibility and better usage of the system. Next up is the battery control feature. That's a brand new feature which can be used, for example, at the end customers on the app. So if you have a power outage ahead, so you know there is a storm coming up, a planned grid outage from your grid provider, the customer would just jump onto the SolarWeb app, go to the battery control section, and then, as you can see here on the left-hand side, hit the start button. So what it actually does, the inverter will then charge up the battery until the battery is full to the set SOC, as in the web UI, and will keep it there or locks the charge and discharge for 24 hours, or until the event happens, or until the customer clicks on the unlock or stop button. So if you want to have a quick look at a quick tutorial, please scan the QR code here on the right-hand side. Here's how it looks in action. So you activate it with the start button. It charges to the max SOC. So it'll usually charge with 1.5 kilowatt if PV is not present until it's full. So the plan for the future is to make that adjustable depending on your grid provider, max grid charge allowance, and certain other things to do. So it's a quite handy feature if you have that blackout coming up for whichever reason. Now let's have a look at our full backup setup range. So this is how on a SIMO Gen 24 Plus, our three-phase version of the inverter, a full backup setup will look like. We have our switchover components as here, K1 and K3, various circuit breakers, and direct connections to the AC terminals. Important, and they will be always the same, after your main breakers, please install a smart meter at the feed-in point. That's one of the reasons, or one of the points where the system notices that it needs to change over into backup mode. So I won't go into any more detail on that wiring in detail here. We have some control wirings going back, actually 5 wires going back to the pilot board with the integrated inputs and outputs connected to it. Another possibility to do that, the full backup, is with our backup controller. So the backup controller is an 8 DIN space device where you don't need to have any additional backup switchover components. It's a 3-phase automatic switchover, which can also be used for single-phase application if needed. We have 35 amp per phase, max power put through, and a temperature range designed for Australian harsh conditions. The -20 not so much, but the +60 certainly. Here a very quick and brief run through on what is where on the backup controller. Starting at the top, we have our neutral reference connection to the Fronius smart meter. Then going on the left, we have 2 LEDs. One LED is the blue one, which indicates backup is active, so we're in backup mode. The green LED would be lit up and active if we have grid connection, if everything is well. And here on the bottom, the push-in contacts are actually for the smart meter connections and the connections towards the Gen 24. Here on the left-hand side, these 3 terminals, as indicated here by the little grid symbol, is the connection towards the smart meter, so towards the grid side of the property of the house. And on the right-hand side, where we have more terminals, that's actually where it goes to the backup loads and the inverter. Let's have a brief look on how that actually fits all together and how you would wire that. So we wire our normal power meter connection. In this case, it's a 3-phase property. So we wire all 3 phases to the power meter, wire it directly into the backup controller. And then we have our neutral reference. Next up, we would wire our essential backup loads. onto the left-hand side of the terminals or the left terminals. And then we would easily connect all 3 phases from our SIMO Gen 24 directly on the right-hand side. And the only thing which is needed now is to have the IOs or the communication lines connected. As you can see here, the beauty is here that on the backup controller, you only need to have 1 wire going back from the backup controller to the Gen 24, because we can actually directly link the cables or wire through the cables from the power meter, which we can see here then in the next step directly. Here we go. And last up. So that leads us onto, if you don't want to have your own backup designed, or you can actually purchase a backup box, for example, the one from Noark, which we just going to see now. And yeah, I'm very excited to see the new option and the new opportunity for the new backup box. But if you do want to have more information about the backup controller as well, here is also another QR code which leads you through that. Yeah, now I'm excited to see what we have in store for the new solution.
Marcus, thanks very much for that.
Thank you.
Lots of good stuff to cover there, right in time for battery rebates happening all over the place. I'm sure there'll be Fronius will be in the frame there for sure. So now I'll hand over to Richard from Noark, who will talk just through their new backup box with CATCH Power built in, designed specifically for Fronius. Over to you, Richard.
Thank you, Scott and Marcus, for the presentation. So a little bit of introduction first. So my name is Richard, and I'm from Noark, Australia. We're based in Sydney, and I'm the technical director of the company, and I'm mainly looking after the product and service, especially on the switchboard business. So absolutely, the backup box, we see a very strong kind of demand lately in light of the new federal and state battery rebate. And we're almost running out of stock, and we've managed to secure a few just for the new version with CATCH Power. So today we're going to talk about that. So let's just get straight into it. So Noark is known for its component, especially on the DC side. We've supplied lots of DC double pole and miniature circuit breakers and lots of multi-case circuit breakers to the solar industry through, especially through off-grid solar, to protect the system, especially between the batteries and inverters. But also we are a manufacturer of switchboard. So I think one of the benefits of having Noark Backup Box is that we are not only the manufacturer of components, enclosure, but we are also doing all the production for the whole solution, including the backup box itself. And furthermore, we are very experienced in switchboard manufacturing. You can see that apart from the backup box, we have all sorts of other products, such as the grid protection board, and also main switchboard, DC combiner box for commercial or utility scale solar farms, and backup box like this one. And this particular product is developed and assembled in Sydney, Australia, and it's supported by local teams. So if you have any questions on site, just give us a call. We have a hotline that we can support to diagnose and make sure that the product is correctly connected and every component is working properly. And we're very honored to collaborate with two great brands, CATCH Power and Fronius, to offer this alternative to the installers to make their life easier, and to have this battery functions, full backup function, well situated, with all the incoming battery jobs coming. And last but not least, this is a very straightforward enclosure and it's plug and play. We have very clear instructions, diagrams provided with the backup box. So just connect it with according to the instruction, and you'll be all right with the backup function. So here is a brief view of the box and the layout of the components itself. And our first generation was a backup box with a Fronius smart meter, both single phase and three phase. And it became very, very popular. And this is a upgraded one that we incorporate the CATCH control to achieve more powerful function from CATCH Power. And you can see that here is the CATCH control dual channel. And this is the K3 DC relay mentioned by Marcus in the Fronius application guide. And as well as this is the K1 contactor. And we also add this RCBO for control load that can be enabled by the CATCH control. So these are the two kind of critical components here, the K1 contactor and the DC relay that enable the backup function and switching between the inverter supply and the grid supply. And apart from that, you can see all the other circuit breakers to be connected to different sources or loads. So this is a more detailed diagram that basically demonstrate how each components are connected, which is also done according to Fronius guideline. So for example, the first 63 amp one pole MCB goes to the grid supply. And here you can see this one goes to the normal loads, which is non-essential loads that you don't need to be backed up when there's a grid failure. And this MCB goes to the backup loads, and this 32 amp goes to the AC output of the Gen 24 Plus. And we do also supply a 63 amp C63 as a backup, which is supplied with the box just in case that you have a inverter that which the capacity is higher, for example, a 10 or 12 kilowatt. And here's a contact that is controlled by the CATCH Power for the control load, and this is the RCBO that you can connect to that load. And on the right-hand side, there are a couple of terminals that we pre-wired to the different relay and contactor that goes to the Gen 24 data manager or the Gen 24 IO board. And so everything else is pre-wired in this box. What you need to do on site is basically connect the AC cables to the grid, to the main switchboard, to the dedicated loads, to the inverter, and also the Gen 24 IO. And here is another single eye diagram that we supplied with the board. You can see this is a more detailed. And with this one, you can easily understand how this box works or how the full backup function of Fronius inverter works. And if there's anything wrong with the backup box, you can easily diagnose according to this drawing as well. Yeah, I think that's pretty much it. It's very straightforward. What I want to mention at the last is this one is available now from Trazor, and we have very limited stock at the moment, but we have more coming in later this month. Hopefully it will be just in time for July for the coming battery jobs. But if you are one of the lucky ones that use this box, just let us know if any feedback, anything that we need to approve. You can reach us by support@noark.com, or we have a hotline, the 1300 number. You can give us a call if there's any issue with the installation. Yep, that's all from my side. Over to you, Scott.
Good on you, Richard. Thanks very much for that. All right, I guess that just leaves me. So just a little introduction on who is CATCH Power. So there's some of the team there at last year's All Energy, but we're an Australian manufacturer of an engineering company of a product here in Australia that helps solve problems for installers, but also have more dynamic installation for system owners. And we're looking at opening up access to load control, control of inverters, greater visibility, and helping with compliance at the site. Electric home. So we're fast moving towards the all-electric home. That could be, everything that's electric, but it could also just mean installing solar. As soon as you install grid-connected solar, you are taking your customer on a stage towards an all-electric home. And as soon as we start doing that process, we have to start thinking about how do we as an industry interact with the grid, because there's pressures on that now. How do we extract the most out of this system? And this is what we're going to talk about today. Just as a definition there, I'll be talking a little bit about consumer energy resources. So that's really anything behind the meter. But the major things is the solar, the inverter itself, solar generation, the batteries that it's connected to, electric hot water systems, air conditioners, and pool pumps are the major CER behind the meter. So this is the installer's reality. We've got lots of pressures on the DNSP, from the DNSPs as to how solar will be installed. These things are changing all the time and getting more stringent. We've got combinations of different types of phases, whether it be split phase, single phase, or three phase, and how to control loads across those phases. We've got mixed brands of inverters, be it across this on the same system or across phases again. And we've got also demand for visibility. And in this case, when we talk about visibility, we're not just talking about monitoring, but we're talking about how do I get feedback from my system as the system owner, or even as the installer, to know that this system is working for me as hard as it possibly can. That's what we see as visibility. So we've narrowed this down to 4 key things that are important for that a solar installer needs to be considerate of, and that is compliance, flexibility, control, and visibility. So let's talk about those things in a little more detail, and then we'll tie it all up. So compliance is really difficult, and it's getting more difficult as we go along. The things like what happens with legacy systems. 40% of installs these days involve a system that involve an installation where there's a system already on the house. So how do I manage the export limit across those sites, or some sort of DNSP interaction with that site when I've got mixed brands? The CSIP requirement says that there should be a single gateway device for a site. That's really difficult if there are multiple inverter brands. And to throw away or to take away an existing system that's on a site just to comply, it really is against the ethos of our industry. We want to use systems that are working and manage them as we can. So these are the things that are. This is a very challenging aspect of an install that's happening more and more across the country. Flexibility. So things are going to change. Things how you install now, the system that you're installing now is not necessarily the system that is going to be the best for the customer in the future. So a great example of that is what if the customer decides to change retailers? Will the system be able to respond, be programmed, be managed in a way where they can extract the most from that system if they change retailers? The extreme case would be Amber, who is changing the price not changing the price. They are giving the owner access to the market price every 5 minutes. But there are also other bespoke retailers that are doing things like free power through the day and those sorts of things. In those cases, you want to be able to have a system that can have the flexibility to change those circumstances. It could be a new addition. I mean, this is the thing that will be faced by installers a lot in the future, in the very near future, is just adding to an existing system. So adding batteries to an existing system. Does the system have the flexibility to cater for that, and for that entire system as it is now, as it will be with the new batteries? Can I manage that site to the best outcome for the customer? So you don't want to have a system that locks you or your customer out of the changing landscape of this industry into the future. Control. So this is really where the orchestration happens. So things to consider here is, how do I stop batteries discharging into a certain load? Electric hot water and EVs are classic, where if the way that, depending on how the system is wired, the batteries, the hybrid batteries may be, without the control of the design of the system, discharging into these loads, and this may not be ideal. In fact, in most cases, it won't be ideal for outcome for the design of that system. So the alternative is to exclude these loads from the hybrid system. Well, that's not a good idea either, because now you've got these large loads that are no longer part of the energy mix. Well, all this generation and stored energy, these loads that can no longer be playing a role in that. So there has to be greater control. It could be a case of subboards. You know, how do I involve loads on other boards that are physically removed from the main switchboard? And same thing again, as I mentioned earlier, with multiple brands. You want to be able to control those brands, and control that system regardless of the brands or the batteries that are connected to it. This is really important, and it's something that's happening more and more as more solar goes in. And then you've got examples of sites that are export limited to 0. How do I charge AC coupled batteries? That's a real challenge and something that needs to be considered. So how do I control the battery, the inverter, the load? In summary, how do all these things, how can I bring all these things together? Now, visibility is, as I said, it's more than just monitoring. It's being informed about how my system is performing, how the system should be performing from a point of view of an installer. So if a DNSP is curtailing the output of a system, how do I know that? How do I know that that isn't, as a system owner, how do I know that that isn't just a poor performing system when it's just curtailment because there's lots of generation at that particular time? Or what if my system is curtailing because the price of exported solar has gone negative, and now the inverter is being turned down to protect me from a bill that I shouldn't have to have because my system is being controlled. I want to know about that. You as the installer needs to know about that. So visibility is really crucial on systems when it comes to system design. This is where CATCH Power comes in. Surprise, surprise. So all of those challenges, those 4 main challenges or considerations for when you're designing systems and moving towards your electric home, control, visibility, flexibility, and compliance can all be solved with CATCH Power using CATCH Control. So it's not just an energy meter that controls a load. It helps with all of these things. It helps with multi-brand inverters on a site. It manages loads, whether they be on a subboard, whether it be across phases. It manages batteries across phases, split 3-phase or single phase. Automatically adjusts to DNSP changes. CATCH Power is integrated with all of the CSIP requirements at the moment across the states, so Victoria, South Australia, Queensland, and we're working towards being integrated in WA for their battery rebate. And we're also in touch with the various DNSPs in New South Wales when they turn on their backstop requirements as well. So CATCH Power is ready for those things that are coming. We offer full visibility of the system and the system performance to installers and their customers, showing the performance of the system, savings at any particular time, exports, and whether they're being varied by the DNSP or by the market, the retailer, and overall performance of the system. And of course, the last critical piece is control of that system. So optimizing batteries to make sure that they're not discharging at a time when the energy is free or not discharging into loads that aren't, you prefer not to be powered by the batteries, EVs and hot water, and a whole lot of other things around control. So this is really the orchestration piece that unlocks all of these different aspects that should be considered as part of the way solar is designed now. So that's me done, I believe. All right, very good. So now I'll stop presenting and we'll open up to the floor and see if anyone. And thanks for Marcus from Fronius and Richard from Noark for participating in this webinar. And we look forward to working with you guys in the future and your customers.
Absolutely.
Thank you so much.
Thanks, everyone.
Thanks, everyone.
Great evening. See ya. Bye.
See you soon.